Now we're going to do D, which we are given this sequence here and we are told that it's a geometric sequence. The first part of the question is to find T6, right? So D, we have 27 over 4, 9 over 4, 3 over 4, goes up to 1 over 2, 9, 1, 6, right? So the first part of the question, we are asked to find T6, right? For us to find T6, we must first find the general term of the sequence, which our A value is equals to 27, we rewrite that. So our A value for this sequence is equals to 27 over 4. Our R is equals to T2 over T1 equals to T3 over T2, right? So my R is equals to my T2, it's 9 over 4, divided by my T1, which is 27 over 4, equals to 3 over 4 divided by 9 over 4. Please punch this in your calculator so that we find our value of R, which I found it to be R equals to 1 over 3, right? So I have my A value, which is equals to 27 over 4, and my R, which is equals to 1 over 3. General term is equals to A R to the power of n minus 1 T, n is equals to 27 over 4 into 1 over 3 to the power of n minus 1. And then now I can find my T6, right? So my T6 is equals to 27 over 4 into 1 over 3 to the power of 6 minus 1. Punch that into your calculator. You should get 1 over 36. So that is my final answer for this problem here. We are done with this part of the question. So my T6 is equals to 1 over 36. So the second part of the question is we are asked to find the value of A if T of K is equals to 1 over 972. So T subscript K is 1 over 972. What is K? We found the general term of the sequence to be 27 over 4 into 1 over 3 to the power of n minus 1, right? And let's write it in terms of K. Tk is equal to 27 over 4 into 1 over 3 to the power of K minus 1. My T subscript K is 1 over 973 equals to 27 over 4 into 1 over 3 to the power of K minus 1. And then to find K, divide by 27 over 4. Divide by 27 over 4. Punch this into your calculator and then you should get an answer of 1 over 6561, right? And then we're just going to say equals to 1 over 3 to the power of K minus 1, right? And then from here we're just going to expand this part, so it's going to be 1 over 6561 is equals to 1 over 3 to the power of K 1 over 3 to the power of minus 1, right? And then what you're going to do is divide. So we are having 1 over 6561 equals to 1 over 3 to the power of K 1 over 3 to the power of minus 1. So we divide by 1 over 3 to the power of minus 1, both sides 1 over 3 to the power of minus 1. And then you punch this into your calculator, so this is to the power of minus 1 by the way. And then you punch this in your calculator, you have 1 over 3 to the power of K is equals to 1 over 19683. So this is 9. And then now we need to simplify this further. So it's 1 over 3 to the power of K. Because the base is 1 over 3, change this into a base of 1 over 3. But for you to do that, you need to change this into a base of 3 first. So what is 3 to the power of whatever number giving you 19683? So you're just going to punch in any value there. You can start from 1, 2, 3, 4 up until you get that answer. What I got is it has to be 3 to the power of 9. You're going to get 19683, right? So now you have that. You're going to rewrite it properly into 1 over 3 to the power of k is equals to 1 over 3 to the power of 9. So the bases are the same, which is 1 over 3, 1 over 3, and the exponents, we just drop them. So k is equals to 9. So that is your final answer for this part of the question. So k is equals to 9 for this problem here. Now let's do the third part of the question, which says that how many terms are there in the sequence? So we know that the sequence ends at 1 over 2916, right? So we're just going to write the formula first, which is t of n is equals to 27 over 4 into 1 over 3 to the power of n minus 1, but we are given that Tn is equals to 1 over 2916 here, right? So, so it's going to be 1 over 2916 equals to 27 over 4 into 1 over 3 to the power of n minus 1. Divide by 27 over 4, both sides, and then punch this in your calculator. So this is 4, by the way. You'll get 1 over 3 to the power of n minus 1 equals to, you're going to get 1 over 19683, right? And then what you're going to do is this: you're going to expand this portion here. It's going to be 1 over 3 to the power of n multiplied by 1 over 3 to the power of minus 1 equals to 1 over 19683. So you're going to divide this. You're just going to say divide by 1 over 3 to the power of minus 1, divide by 1 over 3 to the power of minus 1. Punch this into your calculator and tell me what you're getting. So this is what I'm getting. So we have 1 over 3 to the power of n is equals to 1 over 59049, right? Change this, because the base here is 3, so change it into a base of 3 to the power of a certain number, right? So you're just gonna put in any number here, like to test and see if it's going to give you this 59049. You can test 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, up until you get that specific number. So you're gonna have 1 over 3 to the power of n equals to 1 over 3 to the power of 10. Excuse me, so to rewrite it, 1 over 3 to the power of n equals to 1 over 3 to the power of 10. And then you drop the exponents, so therefore n is equals to 10. So that is your final answer for this problem here. Okay, so now we're going to do E, which, if you can see, is the same as the previous question that we did. Almost everything is just a change of numbers. So we are given this geometric sequence here, which the first part of the question, you're asked to find t of subscript 8, right? So you have so this is E. You have minus 320, you have 160, you have minus 80, and it goes all the way up to minus 5 over 64. So the first part of the question, you're asked to find T8. We know very well that we can't find T8 without finding the general term of the sequence, and you know that this is a geometric sequence. Alright, so we're going to say Tn is equals to AR to the power of n. Our A value is equals to minus 320. My R is equals to T2 over T1 is equals to T3 over T2. Right, so T2, it's 160 divided by T1, which is minus 320, equals to T3 minus 80 over 160, right? So punch this in your calculator and tell me what you're getting, which what I got here, it's minus 1 over 2, so that is my common ratio for this problem here. And then my general term would now be AR to the power of n minus 1. Okay, I made a mistake here. And then my A value, it's minus 320. And then my R, it's minus 1 over 2 to the power of n minus 1. So this is my general term of this geometric sequence. Now we'll be able to find T subscript 8, which is equal to minus 320 into minus 1 over 2 to the power of 8 minus 1. And then the final answer for this problem here should give you 5 over 2. Okay, so we're done with this part of the question. So now you know that the T subscript 8 is actually 5 over 2. Now the second part of the question, we are asked to find the value of k if tk is equals to minus 5 over 16. So what is k if t subscript k is minus 5 over 16, right? So we're going to use our general term here, which is Tn is equals to AR to the power of n minus 1, but we found Tn to be equals to minus 320 into minus 1 over 2 to the power of n minus 1. We want the value of k, so let's write everything with respect to k. Right, k minus 1, and then tk is equals to this here, so it's minus 5 over 16 equals to minus 320 into minus 1 over 2 to the power of k minus 1. So this is k minus 1, and then divide by minus 320 both sides. So what we're going to have is 1 over 1024 equals to minus 1 over 2 to the power of k minus 1. We expand this here, so it's 1 over 1024 equals to minus 1 over 2k multiplied by minus 1 over 2 to the power minus 1. And then this is what you're going to do. So you have 1 over 1024 equals to minus 1 over 2 to the power of k minus 1 over 2 to the power of minus 1. So we divide by minus 1 over 2 to the power of minus 1 divided by minus 1 over 2 to the power of minus 1. Right? So what you're going to get here is minus 1 over 2048 equals to minus 1 over 2 to the power of k. So we need to change this into the same base of 2, right? To change it, you say 2 to the power of, we're going to choose any number to up until you get 2048. So which what I got is 2 to the power of 11, right? 2 to the power of 11 is equals to minus 1 over 2 to the power of k. So what you will do here is this. So you're going to say minus 1 over 2 to the power of 11 is equals to minus 1 over 2 to the power of k. So therefore k is equals to 11. So that is the final answer of this problem here. Okay, so we found k to be equals to 11. So the third part of your question is to identify the number of terms in the sequence. So what will help us is knowing that then this is the last term of the sequence. T of n is equals to 1 over 2, 916, and 1 to identify n, right? So we're going to use our standard, or should I say general, equation of an arithmetic. So we're going to use our standard equation of the geometric sequence. So T of n is equals to AR to the power of n minus 1. T of n is equals to my A, which is minus 320, my R, which is minus 1 over 2 to the power of n minus 1. And then my T of n is this one here, which is 1 over 2, 916 equals to minus 320 into minus 1 over 2 to the power of n minus 1, right? So we divide by minus 320 both sides, and then you punch this into your calculator. You should get an answer of minus 1 over 4096, which is equals to minus 1 over 2 to the power of n minus 1, right? So okay, so you should get an answer of minus 1 over 933,120 equals to minus 1 over 2 to the power of n minus 1, right? And then to simplify this here, we're going to say minus 1 over 933,120 is equals to minus 1 over 2 to the power of n multiplied by minus 1 over 2 to the power of minus 1. Can divide by minus 1 over 2 both sides, minus 1 over 2, and then we will have something like this. Okay, so now we're going to do the third part of the question. So we want to identify how many terms are there in the sequence. We know that the sequence is minus 320, 160 minus 80 goes all the way up to minus 5 over 64, right? And our t of n, which we found in the previous question, is equal to minus 320 into minus 1 over 2 to the power of n minus 1. And in this case, this is the last term, right? So it's going to be minus 5 over 64, right, is equals to minus 320 into minus 1 over 2 to the power of n minus 1. So to find n, since it's what we are looking for here, right, we need to divide by minus 320 both sides, divide by minus 320 both sides, and the answer that you need to get is 1 over 4. It's negative 1 over 4096 equals to negative 1 over 2 to the power of n minus 1, right? Going to expand this, we'll have minus 1 over 4096 equals to minus 1 over 2 to the power of n, multiplied by minus 1 over 2 to the power of minus 1. Divide by minus 1 over 2 to the power of minus 1. Divide by minus 1 over 2 to the power of minus 1. So minus 1 over 2 to the power of n is equals to, so you're going to punch this into your calculator and you should find an answer of 1 over 5 So you should find an answer of minus 1 over 8192, right? And then now, because here it's 2, you need to change this into base 2, right? For us to change that, you can say 2 to the power of, I don't know, choose a number. Just say 2 to the power of 1, 2 to the power of 2, up until you get this answer here, right? The final answer. So what I got was this. So I got 2 to the power of 13 gave me 8192, right? So once I have that, now it becomes a lot easier to solve the problem, because you will have minus 1 over 2 to the power of n equals to minus 1 over 2 to the power of 13, right? And then which is going to be minus 1 over 2 to the power of n equals to minus 1 over 2 to the power of 13. Then you drop the exponents, since bases are the same, so n is equals to 13. So this would be your final answer for this problem here. Okay, so now we're going to do f, which we are given this sequence here and we're told that it is a geometric sequence, and we are asked to find the values of x, right? So we're having a sequence, so this is f, we're having a sequence of x minus 5, 2x minus 4, and 6x, and we're told that this is a geometric sequence, right? So what defines a geometric sequence is the common ratio, right? So for us to find the value of x, we need to use that common ratio, which is t2 over t1 is equal to t3, over t2. So what is t2? t2 is 2x minus 4. So this is term number 2. Divide by term number 1, which is x minus 5, equals to term number 3, which is this one here. 6x divided by term number 2, which is 2x minus 4. And then you do your cross multiplication. You're going to have 2x minus 4. 2x minus 4 equals to 6x into x minus 5. And in this product here, you should get 4x squared minus 8x minus 8x plus 16 equals to 6x squared minus 30x, right? And then you collect the like terms, so this and this transposes to the other side and this to the other side. So you have 4x squared minus 6x squared minus minus 16, because it's 8x minus 16x plus 16 minus or plus 30x, right, equals to 0. Why am I saying plus? Because here it was minus. Okay, so we subtract these two, we come to have minus 2x squared, and then this and this you should get plus 14x, and then plus 16 equals to 0. So you divide by minus 2, should get a standard form of x squared minus 7x minus 8 equals to 0. So x squared minus 7x minus 8 equals to 0. You factorize it. You have x and x, 8 and 1 as the factors, and then 8 is negative, 1 is positive. So x equals to minus 1 or x equals to 8. So these are your values of x for this problem here. Okay, so now we're going to do G, which we are given the sequence here, and you're told that it is a geometric sequence, and the first part of the question is to find the value of x. So G, given x plus 1, x minus 1, x minus 2, and this is a geometric sequence, and to find the value of x of this problem here, we're going to use, since it's a geometric sequence, we're going to use the common ratio, which is constant throughout. So it's going to be t2 over t1 is equals to t3 over t2. t2 is x minus 1 divided by t1, which is x plus 1, equals to t3, which is x minus 2, divided by t2, which is x minus 1. And you do your cross multiplication, so it's x minus 1 multiplied by x minus 1, right, equals to x plus 1 multiplied by x minus 2. And then here you're going to have x squared minus 2x minus or plus 1 equals to x squared minus 2x plus x minus 2. This x squared is going to go away. We have minus 2x plus 1 equals 2. So you add these like terms, going to have minus x plus minus 2. So this is minus 2 by the way. And then we transpose this x to the other side. We have minus 2x plus x equals to this one to the other side. We have minus 2 minus 1. We have minus x equals to minus 3. And divide by negative 1 both sides. So x equals to 3. So that is your value of x for this problem here. And then the second part of the question is to find the general term. So you have your value of x, you know your sequence, it's x plus 1, x minus 1, x minus 2. You substitute the x being equals to 3, so it's going to be 3 plus 1, 3 minus 1, 3 minus 2. Here it's going to be 4, here it's going to be 2, here it's going to be 1, right? So to find the general term, we know that this is a geometric sequence, right? And the value of a is equals to 4, the value of r is equals to t2 over t1 is equals to t3 over t2. So your r is supposed to get 1 over 2 as your common ratio. So Tn is equals to ar to the power n minus 1. Tn is equals to my value of a, which is 4, my value of r, which is 1 over 2, so it's n minus 1. So this is going to be my final answer for this problem here. Okay, so now we're going to do h, which we are given the first 3 terms which are considered to be a geometric sequence, and these 3 terms which are considered to be an arithmetic sequence, and we are asked to solve for x and y. So what we're going to do is this: we're going to write down, so this is a geometric sequence, and then 1x plus 1, y plus 1, so this is an arithmetic sequence. So to solve for x, firstly what you need to do is you need to apply the right properties. So for example, this is a geometric sequence. How do we define a geometric sequence? By a common ratio, right? So if this is term number 1, term number 2, term number 3, so a common ratio would be t2 over t1 equals to t3 over t2, right? So what we will have is y over x, because term number 2 is y, term number 1 is x, equals to term number 3, which is 8, over term number 2, which is y. So cross multiplies is going to be y squared is equals to 8x. So this would be our equation 1. And then we come here to the arithmetic sequence. What defines an arithmetic sequence is a common difference, right? Which is t2 minus t1 equals to t3 minus t2. So this is t1, this is t2, this is t3. So equals to t2 is equals to x plus 1, alright? And then we put it in brackets, so it's minus t1, which is 1, equals to t3, which is y plus 1, and then minus t2, which is x plus 1. Simplify this further, you have x, so this plus 1 and this minus 1 go away, so it's equals to y plus 1, which is this one here, minus x minus 1, which is this one here, right? Because the negative will multiply everything that is inside. And then transpose the x to the other side, we have x plus x equals to y, and this plus 1 and negative 1 will cancel out. So you have 2x is equals to y as equation 2. So we can substitute this here in equation 1, right? So where we see y, we put 2x, or we see y squared even. Where there's y, we're going to put 2x, so it's going to be squared equals to 8x, right? So here we're going to have 4x squared is equals to 8x, right? And then we transpose the 8x to the other side, so it's 4x squared minus 8x equals to 0. Divide by 4 all sides. We have x squared minus 2x equals to 0. Then we factorize x, right? And then my x is equals to 0, or x equals to 2. So that's my values of x, but what is y? Remember, this is the equation for y, where y is equals to 2x, right? But x is equals to 0, or x is equals to 2. So when x is equals to 0, y is 0. And then when x is equals to 2, y is 4. So we are done finding the solution of x and y for this problem here.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.